In this video, we are going to look at what is called the E1 reaction. E1 reaction is a sort of elimination reaction, okay? And E1 elimination reaction occurs in two steps. Only two steps are involved in the mechanism, all right? Now, the two steps that are involved is the formation of what we call carbocation intermediate. So we have the formation of carbocation intermediate, then followed by the elimination of what we call algae, which is leaving group. Okay, so these are the two basic steps involved in E1 elimination reaction. Okay, formation of a carbocation, carbocation compound contain something like this, carbon with a positive charge, then you have the substituents all around it. So that's what a carbocation is. So now I'm going to make use to illustrate this with an example from the question I've been sent. A reaction, equation of reaction like this. You have CH3, then we have CH3. You can write this as H3C, right? So this is CH3, and then you are given this C with an H here, then OH. Now, if you've not watched the previous video, you need to watch to see how we came about this non-bonding pairs of electron. I've explained that in the previous video. You can check this video description to see how we came about all of this. All right, so let's proceed. Then we have underbond here with CH3. All right, and you were told that this process is under the influence of an acid. This acid is serving as a catalyst. You will get to understand why it is serving as a catalyst in this reaction towards the end of this video. So the product you were given was this. We have double bond here, then we have CH3, then we have carbon, then we have CH3 at the top, then single bond here, then we have CH3. So essentially we want to show how this product was formed. As you can see, this is an alkene. All right, this is 1 2 3 4, 1 2 3 4. So this basically butene, right? But the substituted butene, we can try to name it if you want. 1 2 3 4, then you have 2 methyl 2 3 dimethyl butene, butene. So now, with that being said, how are we going to show the E1 mechanism or reaction for this what we've been given? So like I said, the first thing that will happen is the formation of a carbocation. All right, so I'm going to wipe off this product because we are going to account for this product. All right, bear in mind the acid is involved as a catalyst. So what basically happens is that if you look closely here, over here, you can see oxygen. It's very electronegative. It's more electronegative than carbon. So that means it can withdraw electron from carbon. All right. So what oxygen is going to do is going to withdraw the bonding pairs of electron, which are this, to itself, right? So when it does that, right, it's going to pick up the proton, right? So basically we are going to have let me wipe this arrow. I'm not showing the mechanism. We are going to have this intermediate where we have, remember, oxygen is picking up. You can see oxygen is picking up the bonding electron. Look at the bonding electron to itself, meaning that carbon will be deficient, meaning there's going to be a positive charge, right? So we're going to have this structure H3C, remember, right, with carbon with CH3 over there, then with another CH3 here, right? Then look at this bond. I'm going to represent that. So I'm going to put bond here. Then you can see over here, as the next thing I'm going to write. I'm going to write carbon with hydrogen, right? Remember, it has this. Okay, so I have it here, which is CH3. So because oxygen is withdrawing this bonding electron to itself, carbon is going to be a partial positive charge. This is basically our carbocation, right? Let's not forget there's CH3 here. So you see, now as this is happening, remember oxygen is taking up this proton, right? So we are going to have plus what? Water. This is oxygen, right, with the pairs non-bonding electron. Like I said, you have to watch the previous video to understand why we have these dots. Basically, the dots are these dots. So how do we come about them? I've explained that in the previous video. So we have hydrogen here, which is hydrogen here, and the hydrogen that's picked up. So we have water, right? So this is plus. So this is basically what we have in the first stage, right? So if you look closely again, now I'm going to rewrite this species here. I'm going to rewrite it so that we explain what's happening there. All right. So I'm going to have CH3, that's H3C, then carbon, then CH3, then we have CH3 here again. Remember, we have carbon here. We have, let me represent the positive charge here. Then I just changed the hydrogen. You can see here, the hydrogen's here. So I'm going to write CH3 here, right? So once I'm done with that, okay, now we have to look at the position of this positive charge. All right, this is one carbon here, this is 2 carbon, this is 3 carbon. Now this carbon is called a primary carbon, all right, because it's attached to one alkyl group, and the alkyl group is this. You see, this carbon is attached to the whole of this, that is one alkyl group, making it a primary carbon, right? So now if you look closely again, this carbon is attached to 2 alkyl groups. It's attached to this one, and it's attached to the whole of this, making it a secondary carbon, right? Now let's look again. Let's look at the next carbon. This is 1, this is 2, this is the third one, right? Now this third one is attached to this one, is attached to this, it's even attached to this and this. So it's attached to like 4. This is more like ordinary carbon here, you can see here. So with that being said, stability is dependent upon the positions of the carbon. So now what we'll do is, since we know this is not the most stable carbocation, right? And we know that this is the most stable, right? This particular one is the most stable. Where is it? This is the most stable. this carbon here is more stable than this. All right, owing to the fact that this carbon has only two alkyl groups, this and this. Can you see? Only two. But if you look at this carbon here cycled, it has this alkyl group, it has this, it has this, it has this. So this is the most stable carbon. All right, so with that being said, we are going to have a way to cause this positive charge to be transferred to this carbon, because this is the most stable, right? So for us to do this, we're going to carry out what is called a shift of this methyl group. There's going to be a methyl shift to the next carbon. So when this happens, we are going to have H3C as usual. Then we have carbon. Since this shift is taking up all the bonds, so we're going to have a positive charge here, right? Remember, there's CH3 below, right? Then we have a bond. Then we have C. Now, the methyl that have shifted is here. Can you see? Oh, sorry, I missed that. So you can see it is here, right? Then just below it is this one. So I have this CH3. Remember, we have this carbon here, this hydrogen, sorry. So I have hydrogen. Can you see what we've done? So we've now shifted stability to the dissolving carbon. This is carbon. Now you can see that this carbon has 1, 2, 3, making it a tertiary carbon because it's the most stable, right? That's our aim, so that we have this, right? So let's proceed. Now that we have achieved these feats, right, we can now proceed again. So this is equivalent to the whole of this. The whole of this now is equivalent to saying, let me put this, let me write this, okay. This is going to be, I can write this to be CH3, which is H3C, as you can see, then with carbon with positive charge, then with CH3, right? Then we have carbon, then we can have, where do we position it? Let's put CH3 still there. I'm basically rewriting this. I'm basically rewriting the whole of this. Okay, so we have CH3, then let's put the H somewhere here. Let me put the H here. Yeah, talking about this H, I'm just changing the position. That's why I'm rewriting this. Okay, so now this particular CH3, I'm going to put it here. All right, so remember, here we have CH3, CH3, right? So this and this are just the same. These two are just the same. I'm just rewriting it, okay? So why I did this is because I want to show the next thing that is going to happen. And what is going to happen is that, remember, we created a water molecule here. You can see we have a water molecule here. This is water molecule, right? So basically this water molecule has electrons all around it. So it's going to pick up this hydrogen over here. So what happens is that we have oxygen, which is the water molecule that was eliminated at the first stage. So it's going to pick up this hydrogen, all right? And once it picks it up, the electron, the carbon to hydrogen bond here is transferred to this one. Can you see? So once this happens, that means this carbon here will be surrounded by how many bonds? If I add one here, let me add it. So I'm going to have H3C, remember, bonded to carbon, talking about this place. Now, just below we have CH3, right? Remember, we are now introducing a double bond here. So you see, that has cancelled the initial plus sign that was here. So we are going to have the carbon, the next carbon, and that carbon has CH3 at the top. Can you see that? Then remember, there's nothing here again, right? That hydrogen is gone because oxygen picked it up. If you can see from here, oxygen had picked it up. So the next thing is this CH3 over here, which I'm going to write here, CH3. So, and plus what? When the water molecule picked up the hydrogen, is going to give us this oxygen. Remember, this is hydrogen, this is hydrogen. So if it's picking the hydrogen, it's definitely going to use its electron to form another hydrogen. So we're going to have something like this. Here I'm going to show you why the acid was actually the catalyst. This H3O plus can proceed with reacting with. Now, before I show you that, you need to know that this is sulfuric acid. Sulfuric acid is represented this way. This is sulfuric acid, hydrogen. Oh, sorry. So we have, what am I doing? There's an oxygen here. This is sulfuric acid. I just want to show you how we came at about H plus, okay? So basically, what happened initially was that oxygen withdrew all its bonding electrons to give you, once this bond is gone, hydrogen here is going to be positive charge. Then we're going to have this, the whole of this one, the whole of this, which I'm going to represent as HSO4 minus. You see, one oxygen, one oxygen, one oxygen, one oxygen. That's 4 oxygen. Can you see? One hydrogen, that is 1 hydrogen. One sulfur, that is 1 sulfur. So that's basically how I got HSO4 minus, right? So this is what now went into the reaction. Okay, so now this H3 ozonium ion can react with this. Now we're going to have H3O plus HSO4 minus. This is going to give you water plus H2SO4. Sorry, let me wipe this off. This is going to give you we're going to have H3O plus HSO4 minus, which I said it will give you water plus H2SO4. You can see that we've generated the catalyst. That's basically how to show that, okay? This is still the acid. So the acid has been regenerated, which tells you that it's serving as a catalyst, and this is water. So basically, this is the product, right? So this is where you stop in showing the mechanism for the reaction in that question.